Well, hello everybody. Got this question yesterday from MyMathLab about how to find the minimum sample size needed for a confidence interval. Okay, and it's not too hard for me to show you how to do this, but I feel like I should give you some background information rather than just jump in and work it. Okay, it just doesn't seem right for me to tell you, well, here's what you do: you use this formula, you plug in these numbers, and you do the math. And in that case, you might know how to do the calculations and get the right answer, but you might lose the understanding of what the big picture is. So it's good to understand the big picture anyway. So with confidence intervals, which whether or not you're trying to solve this problem that I just had up or something else related to a confidence interval, it'd be good to know what's happening. Okay, so as is the case for a lot of stuff that we're working on at this point in the class, there are two things that are interacting with each other. There's a population and a sample. The population is whatever we're trying to study, and we take the sample from the population in order to study it. So the sample comes from the population. And with confidence intervals, at least as far as we're learning them right now, we don't know the population mean. Okay, that's what this Greek letter mu is right here. We don't know that. We know the population standard deviation. We take a sample. We know the sample mean, that's what x bar is, and we know the sample size, that's what n is. Okay, and we want to say something about what we think the population mean is, mu, based on all of this information. And that's what a confidence interval is. And what you do there is you take the sample mean x bar and the low end of the confidence interval, you subtract this number e called the margin of error. And for the high end of the confidence interval, you take the sample mean x bar and you add the margin of error. Okay, so that's like the rough idea without getting too far into the details. Okay, and then we say, well, the population mean, whatever that is, mu, we don't know exactly what it is, but we think it's somewhere between these two numbers. Okay, whatever these two numbers calculate to be. All right, so that's the background information I feel compelled to tell you before I solve this one. So if I want to find the sample size needed to get a confidence interval with a certain margin of error, that's what's happening here. So C means I want a 95% confidence interval. Sigma, the population standard deviation, is 5.2, and E is the margin of error that I mentioned before. Okay, so what sample size? How big does the sample have to be, right? That's what it's asking us, because we take the sample and it's of a certain size, and the size of that sample determines a lot about the confidence interval, so we're trying to figure out the sample size. Okay, here's how you do it. The sample size needed for a confidence interval that's 95% with a margin of error of 1 is like this. Okay, ZC, which we find with StatCrunch on the standard normal, times sigma divided by E, and we square that. Okay, all right, so we're given sigma, right? Sigma is 5.2, so I put that in. We're given the desired margin of error, that's 1, I put that in. The only number I have to find is this ZC right here, which I will find on the standard normal at 95%. Okay, so what I would do from there is I would open StatCrunch, I would go to calculators and normal, and I would select between, because this margin of error number is such that it contains 95% of the area between it and its negative. So I can just put right here 0.95. And that will give me the number that I need. So E is 1.96. Now remember, we find this on the standard normal. That's the normal with a mean of 0 and a standard deviation of 1. So 1.96 is my number, and that's what I have right here. Okay, so that's ZC right there. That's the only number I really have to do any work for. From there, I would calculate this carefully. Some people ask me questions, and I think their real trouble is they're not inputting stuff in their calculator correctly. Okay, so if that could be you, then just do things one step at a time. Like I take 1.96 times 5.2, I'd get 10.192. Then I would take that number and square it. I get 103.877. Okay. So my final answer, since it says round up to the nearest whole number, would be that I need a sample size of 104. Okay. So in order to get 95% confidence on the population mean with a margin of error of 1, I need a sample size of 104. Okay. All right, so that's how we solve this kind of problem where we're looking for the sample size. One more thing, because I do get questions from students quite a bit where I think they're just having trouble with their calculator, okay? What if the E happened to be 2, okay? So say we're doing the same problem, but the margin of error that was given was 2, okay? So I would put it in like this, same way, but just be careful, do things one step at a time and follow the order of operation. So for example, I could say, well, first, what's 1.96 times 5.2? That's 10.192. Then, what's 10.192 divided by 2? That's 5.096. Then, what if I square that? It's 25.969. So that's what I would recommend if you're putting it in the calculator, you think you have all the right numbers, but you're not getting the right answer, okay? That it does happen that if you input numbers in your calculator without parentheses where they should be, then you might have all the right numbers but not get the correct final answer. So one thing that you can do if that's the case is just go one step at a time by yourself and follow the order of operations.